IMF, or the intermolecular forces, are the forces that are present in all compounds, like dihydrogen, ozone, and water, also found within every element when they combine. And these forces are separated into four types, with each having stronger forms. The first is London dispersion forces, and these things are everywhere, kind of like London. I meant Britain, not London. I'm just not very that smart right now. Some LDFs are stronger, and some of them are weaker than each other. Atoms will be stronger. Or we can look at the amount of electrons, more line dispersion. The next one is dipole-dipole. Dipole-dipole is combined with polarity. So if we take carbon dioxide, we can look at the symmetry. If it's symmetrical, it's nonpolar. But if we find one that is asymmetrical, like carbon monoxide, it is. We can also look at the lone pair bonds, the little two dots on top of the central atom. Bonding pairs affect the geometry, pushing them together, causing asymmetry, affecting the polarity, since polarity is just based on an uneven amount of electrons. Or another way to say is that lone pairs cause asymmetry. Why carbon dioxide is nonpolar but CO is, because of the unevenness. Extra note, if you get two polar liquids and mix them, they can mix. If you get two nonpolar and mix them, they will mix. But if you were to separate and mix them together, they can't. Polars and nonpolars can't mix. The next IMF is hydrogen bonding, the easiest one. It's when a hydrogen molecule combines with fluorine, nitrogen, or oxygen. Three are without hydrogen, they're pretty weak. But with hydrogen, with all of this, boiling point increases, and you're happy, because the hydrogen bonding equals polarity, meaning it equals dipole-dipole. And hydrogen bonding is stronger than dipole-dipole. Hydrogen bonding, you know they have LDF, dipole-dipole, and the hydrogen bonding itself. Something extra to know, hydrogen bonding only happens if hydrogen connects with nitrogen, fluorine, or oxygen. Like this compound, it has hydrogen and fluorine, but the hydrogen is only connected to carbon, not fluorine, so it's not hydrogen bonding. The last IMF is ion-induced dipole. This is when an ion, something with a charge, being positive or negative, will be dropped into a polar substance. Now, this polar substance can be water or it can be any kind of polar liquid. The opposite ends of the charge will then point towards it. In this case, sodium is positive, so that means all the O negative ends will turn towards it and create ion-dipole bonds. The last thing you want to know is just that the more IMF there is, the more boiling point there is. This is because boiling point is just the amount of energy required to break the bonds, which is why when more IMF is there, the boiling point will increase because you need more energy.